Using machine learning to forecast price reaction of crude oil over a short time frame, or the immediate effect of the US inventory report on the price of crude oil, the potential to use analytic output from various machine learning algorithms to predict that effect in the future. Let's see if we can do it. Okay, so the team is Shane Flynn, Martin Mohan, Declan Moore, that's myself, and Bolu Abataya. And we have, in a role of successful team, you seemingly need, according to Belvin, a number of little functions. So we need a resource investigator, uses the inquisitive nature to find ideas to bring back to the team. Well, I think that was probably Shane. He's the oil guy. He knows where the data is. He'd love us to investigate the data that we've got. So he's gone out and found us really hard to get data. You know, data at 15.30 price for oil, data at 15.31 price for oil, and he's got the predictors and where to look. The team worker, he helps the team get to using their versatility to identify the work required and complete it on behalf of the team. You know, it's very hard to say because I think Martin's going to fill most of these bloody roles because he's done so much for us. Coordinator needed to focus on the team's objectives, draw out team members and delegate work appropriately. I'm taking that role a little bit. Plant tends to be highly creative and good at solving problems unconventional ways. Well, certainly Martin has definitely been creative at solving the ore problems. So monitor evaluator provides a logical eye, making impartial judgments where required and weighs up the team's actions. I think we all tried a bit of that. Let's face it, I mean, there's only 4 of us. We have to fill a number of the roles. Specialist brings in-depth knowledge, key area to the team. Well, both Martin and Shane was the specialist in the oil price, and Martin really got into ore and delivering the code. Myself and Bolu really were able to rerun the code. We've got a video of that later, and we were able to shape it using different sets of data. Just quickly, we stuck with the most accurate data analysis that we did, which was the 1531, but we did get end of day data as well as a comparison. And then the implementer needs to plan a workable strategy, carry it out as efficiently as possible. Well, we all tried to do our best there, and most effectively use at the end of task to polish and scrutinize the work of error as well. Jesus, is that me? Maybe. Alright, so moving on, we have Shane's literary review. Go Shane.
The oil market tends to react instantly when the inventory report comes out. The price adjusts very, very quickly when this new information reaches the market. However, we could not find any models that determine how the market prices this change in data. It's quite evident from the trading activity around inventory data that traders have built algorithmic models that quickly adjust the price of oil based on the new market data. However, we haven't been able to find any published academic literature regarding how these models are built. It's quite evident from the trading activity around inventory data that traders have built algorithmic models that quickly adjust the price of oil based on the new market data. However, we haven't been able to find any published academic literature regarding how these models are built. We decided that it would be an interesting project to look back over historical price changes and attempt to discern how these models reprice oil based on new inventory data. Most academic research that studies the oil market is trying to predict prices over days, weeks, and months. There's very little research over short-term prices. The weekly inventories report is the single most impactful event in the oil market, and yet there's very little research on it. We thought that by capturing the short-term price difference immediately after the inventories report, we would be capturing and trying to predict the effect of that inventories report on oil. So we took the price at the second that the oil report is released, and again a minute later. We believe that this should capture the impact of the report. Any longer period in this would allow other fundamental factors affect the price of oil.
This is a demonstration of our studio, how it works in order to predict prices of oil on every Wednesday at the time 3:30. At 3:30 a supply report comes out, and at 3:31 the price changes based on the supply report. Can we predict this change? Spoiler, yes we can. Okay. First of all, we load the libraries from the file oilprice.rmd. These are all the packages which we will be using. After all these libraries are loaded, we then load the files containing the data in which we are interested. There are 6 files. They are here: prices, distillation price, crude price, gas price, Cushing, and API. We also make sure the times are correct. These are what these functions here are for. So we run this data and we save it. The data comes out in a slightly better format, more easy to work with, because we need to determine the price at different times. After this is done, it creates several graphs as well if we do a linear regression. We did this in order to check for residuals and outliers. It was noted, however, that outliers are the best way of making a profit. If the price jumps by a lot, then it is a good investment opportunity. So we decided to leave outliers in. It is also important to note that these files created are also put into a directory called figures. This is necessary for the latex report, which we will generate later based on these values. See. In this file we then create all the different charts and graphs that we need, such as histograms, scatter plots of all the different values. These are also in the report which we submitted. Graph of this is a graph of the standard deviation. The predicted price and the actual price are very close. They are in red and blue. After we do this, we then do some more plots. And these create some more graphs and also check for autocorrelation. These files are also stored in the directory figures to be used in the report. So these create the graphs like autocorrelation graphs. Now we come to the interesting part. This is where we generate the models. This is an algorithm list to predict the prices. We use random forest, linear regression, GLM boost, and SVM radial. These are illustrated here. After we generate these models, we also use them to create 2 different ensemble methods, which will also be compared to see which is the best method in order to predict prices, oil price. We split the data into training as shown here. And we run them against our training data, as is shown. After we've generated our model, the prediction now uses the test data. We then predict the difference between price and the price predicted. How far off are our predicted price? This is done here using the test data. Finally, we can say which models are. In the end, we come out with a series of numbers. These values here represent the difference between the predicted value and the actual value in dollars. They are all very close, around $20. The best is XGML Boost, followed by one of the ensemble methods, but the difference is not very large. Okay, thank you very much.
Okay, so the data comes from the US Energy Information Administration, EIA, and it provides the weekly report that's going to move the price between 1530 and 1531. They're reporting on a number of independent variables that we're using, so crude, the gas, distillate, and it's a stock price. So there's an expectation of it and there's an actual. And if it's going to be exactly spot on, then the price isn't going to move. And if there is a movement different to expectation, then it will definitely move. And it correlates, on our data, correlates to that price movement. But the pricing movement isn't great enough really to make a decision on it based on our research. They're CSV files. We were messing around with putting them together. We had to match 1531 data and 1930 data. Sometimes we did it within Excel using VLOOKUPs, getting the dates. It was pretty easy to do. Shane gave us very clean information. We weren't replacing NAs or anything like that. We had it very clean. The regression test was very clear in the graphs that we had a multiple regression. Gas didn't affect it as much as the other four inputs, and so we can see then at the bottom that 0.67 isn't significant, but all of these numbers were significant. And in deployment, they can be used to produce it, but of course the power of the computer is required. You're going to have to run this very fast. You're going to have to automate the instructions. We haven't got nearly that kind of money and clout and power to be able to do that. The important thing is to find out, does it correlate? Could you do it? We believe with enough money and enough more research, there's potential to do that. So future work. I think we need to run this a few times before we start investing. Martin believes that Glimboost provided the better model. for price prediction with an RMSE of 1989. I actually don't understand that because it seems to be middle of the road to. I think he has to explain a bit more to me, but I accept his viewpoint, and that's in our report. The additional analysis, we've done a quick video. Bolu's and myself put together 1930 data, and we reran all the reports that produced 40 things. So if I can just quickly show you the documents, NCI. What I'm going to show you is the data. So we've got closing data we're going to give you, and we've got Martin's original in the figures. Martin's produced an awful lot of data based on 1530, and we're going to give you Bolu's data that he ran on the closing figures, which will have different graphs and different measurements as well. Hopefully I'll be able to just quickly talk you through that. The oil price trend over the 3 years. This is the first 1531 price prediction, going up, going down, and R1 at 1930 shows you that it's a hell of a lot less correlated, and the correlation here is the first prediction here where, very much smooth line, and then by 1930 the pricing prediction of what we're doing is a lot less. It's still just kind of a line, but no, a lot less useful. So power, you got to get in, you got to get out. If you're going to predict this, yes, there's potential of accuracy. Whether you're going to make movement, we're not seeing a huge amount of movement in it, but it is moving. Thank you very much. That's mine.
This is a sample of the end of day data compiling. I'll just wait till it's done before I explain it. I think the reason why we did this is to compare the prices at 1331 compared to 1930 to see how much it differs, because there are other reasons that drives the prices of oil. So we want to see if it could act. The prediction is similar from the original that was run compared to the end of the data. Yeah, as you can see, it's finished running, and all of the predicted plots are so similar. It ranges from 74.3 to 77.5. A graph of the originally predicted data sets and of the predicted price and the new one I just ran, which is the end of that day data. It can be seen side by side. On the left hand side, you can see the linear regression line, and the data set is sparsely distributed and away from the regression line compared to the data that was run at 1531, or that was obtained at 1531, which is close to the regression line.